Hello, and welcome to the first lesson on logarithms. So, a lot of people start to freak out when they hear the word logarithms. Either you learned them before or you've just heard bad things about them. But in reality, they're nothing that new. If you understand how to do exponents, you should understand how to do logarithms. So, the main purpose of logarithms is to solve an exponent. So, for example, when you have an exponential function, y equals b raised to the x. This is a basic exponential function. B is the base, x is the exponent. Now, if you want to find the inverse, you have to switch the x and the y and then solve for y to find the inverse function. So if we were to do that, this is the inverse. Now, our goal is to solve for y. So how in the world do you get y out of the exponent? A lot of people say, oh, what about you get the yth root? But if you do that, you're only going to make things more complicated. If you were to get the yth root, which means raising to the 1 over y, you see, you would have to do that on both sides. You did nothing at all to simplify this. Yeah, you may have moved the y over to the other side, but it's still in the exponent. So at the end of the day, you didn't really solve for y. So the whole purpose of logarithms is to be able to solve this type of problem, where we are trying to get or solve for the exponent. So all a logarithm is rewriting an exponential function so that what you are solving for is the exponent. So to rewrite this in logarithmic form, we say log base b of x is equal to y. Now, this does not mean b raised to the x. This does not mean that. This is log base b. This is all connected. This b is a subscript of the operation log. Okay, log base b, this all comes in one unit. And this is not multiplying by x. This notice I'm saying log base b of x is equal to y. So notice here, I rewrote this now with colors just so we can visualize what's going on here. So this is an equation in exponential form. This is the same exact concept, same exact equal sign, but this time in logarithmic form. So notice here what happened. Notice that the y is no longer in the exponent. We are now solving for y when we put it in logarithmic form. So notice that the base of the exponent is the same as the base of the log. This is called log base b. So they are the same thing. Log base of the log is the same as the base of the exponent. So this here, the b is called the base. Y is the exponent. And x is what we call the argument. X is the argument. The b, the y, and the x are the exact same thing in both equations. But once again, logarithms is very useful for solving for the exponent. We are solving for. So essentially, when you are presented with a logarithm, your goal is to find the exponent that you want to raise the base to so that it's equal to the argument. So it's just reverse thinking. You are thinking in the opposite direction that you would if you are given an exponent. You are now solving for the exponent when presented a logarithm. Let's take, for example, this problem here. B raised to the 2 is equal to 9. If we wanted to rewrite this as a log, we would say log base b of 9 is equal to 2. You see, same base, you are now solving for the exponent, and you're getting log base b of 9. So what do I have to raise b? so that it is equal to 9. Let's take, for example, 3 raised to the x is equal to 27. So here we're trying to solve for, what do we have to raise 3 so that it is equal to 27? The answer, of course, is 3. We know x is 3 because 3 raised to the 3 is 27. But if you wanted to rewrite this as a log, you would say log base 3 of 27 is equal to x. Now, if we wanted to do this problem here, let's take, for example, 2 raised to the 4 is equal to x. 2 raised to the 4 is 16, but let's say we wanted to rewrite this as a logarithm. This would be log base 2 of x is equal to 4. So once again, what do I raise 2? So it's equal to x. 2 raised to the 4 is equal to x. And of course, x here would be 16. How about this? Now let's go in the opposite direction. Okay? Let's say you are presented with a log. Log base 2 of 8 is equal to x. So now you are asked to solve, what does that x have to be equal to? So in order to rewrite this as an exponential equation, I would say 2 raised to the x is equal to 8. So sometimes rewriting logs as exponents makes solving these problems a lot easier because it's we've been used to working with exponents, so rewriting a log as an exponent may be very useful for you. But hopefully eventually you get to the point where you can solve problems like this in your head. But basically you're trying to figure out, what do I need to raise 2 to so that it's equal to 8? And of course the answer is 3. Now let's take, for example, this one. Log base b of 4 is equal to 2. So to rewrite this as an exponent, we'd say b raised to the 2 is equal to 4. And of course, b has to be 2, because 2 squared is 4. But in logarithms, just like with exponential functions, the base cannot be negative. So we do not take into consideration -2 as an answer for this. Now let's do one more. Log base 3 of x is equal to 2. So here, 3 raised to the 2 is equal to x. So here we're trying to solve, what is that x equal to? And of course this is 9, because 3 squared is 9. So this is the usefulness for being able to convert back and forth between logarithms and exponents. Okay, so go ahead and attempt to convert these exponential equations to their equivalent logarithmic equations, and go ahead and convert these logarithmic equations to their equivalent exponential equation. Pause this video, try to solve these on your own. I will give you 5 seconds and I will upload the answer. Okay, so you are not asked to solve for x in these problems, although you can if you wanted to challenge yourself. But these are the answers. These here are these exponential equations written as logarithmic equations, and these are the logarithmic equations written as their exponential equation. Understanding the conversion between logarithmic and exponential equations is critical in order to understand the rest of the lessons in logarithms. This is the basis of it all.